Hello, Algebra 1 students. Hope you are having a great day. Today we're going to be doing section 813. So let me get to my screen here. Well, let's see if I can get to the right screen. There we go. And we're going to be looking at the exact same thing that we've been working on since 811. There is nothing new today about the procedure. There's nothing new about what we're trying to do. Remember, we're still trying to find the factors of a quadratic, which means we're trying to write the area of a generic rectangle in terms of base times height. That hasn't changed. The only thing that's going to change today is the type of problems we give you. There's going to be just a few little twists in there. Okay. So this is question 825. And we're going to be factoring what are known as special cases. Now, this first one isn't going to seem like a special case. It's just in the end and how we write the answer. So again, if you have a printer at home, please print these notes out and follow along. If you don't, that's okay. Just grab yourself a piece of paper and a pencil. Make sure that you are writing these things out as I talk about them. It will really help you. We're going to do 3 examples, and we're going to start with this quadratic. Now I'm going to throw in a new word today. It's called trinomial. And the word trinomial means there are 3 terms. Okay, x squared plus 6x plus 9. And a trinomial means, that word tri means 3. And so that means we have 3 parts. We'd have an x squared piece, we have x pieces, and we have unit pieces if we were making this with algebra tiles. And so remember, we're going to use our 6-step program process. And our first step, and if you want to make a table like this, that's great, but we're going to fill in those pieces. So step 1, you need to make your generic rectangle. Those of you who still want to use the algebra tiles, that's fine. Not every question I give you works out so nice with algebra tiles. That's why I'm pushing you to the generic, but this one is fine. Go to your algebra tiles, get 1 x squared piece, 6 x pieces, and 9 units, and see if you can make yourself a rectangle. But remember, when we make our generic rectangle, we know that the x squared, the large pieces, go in that bottom left, and the units go in that top right. What we talked about in our 812 lesson is these 6 x's. We don't know how to split those 6 tiles up. We don't know if we're going to make it 1 and 5, 2 and 4, 3 and 3. We don't know that. Not yet. And so we have to do some math in order to figure that out. But for right now, we just put question marks there. We know that eventually it will add to 6x because we can only use 6 of those x tiles. Okay. Once you've made step 1, your generic rectangle, you need to do step 2, which is to multiply that known diagonal. So x squared times 9, pretty straightforward, is 9x squared. And this is what we were talking about in 812. You've been doing the diamond problems since 6th grade, if you've been in our district since 6th grade, because this is where you need to use it. What multiplies to 9x squared? Because we know both diagonals give us the same product. So we know that those 2 question marks have to multiply to 9x squared. But we also know they have to add to 6 because we only have 6 tiles we can use. And so we set up our diamond. So what multiplies to 9x squared and what adds to 6? I really just focus on the numbers. What multiplies to 9 but adds to 6? Well, this one is pretty straightforward. We only have 2 choices. 1 times 9 gives me 9, but when I add that, that's 10. And 3 times 3 gives me 9, and that's the right one because 3 times 3 is 9. 3 plus 3 is 6. So I solve my diamond. Those are going to be 3x and 3x. Okay. And then I go ahead and I fill in my generic rectangle. I now know what to do with those question marks. Okay. This is also the hard part because you have to be able to figure out the base and the height. And in this case, the base is x plus 3 and the height is x plus 3. And that's what makes this one a really unique, what we call quadratic. It's because we have the exact same base as the height. So the base is x plus 3 and the height is x plus 3. And remember, whenever we have something that's multiplied by itself, like 3 times 3 or 4 times 4, we use shorthand, which is exponents. So we would say 3 squared or 4 squared. It's the same with this answer. So notice how this answer is written. It's known as 3 plus x squared. It just means you have two of those x plus 3's. Now that you're going to see that. This is what's known as a perfect square trinomial. Now, I'm going to move out of the notes for just a second, and I'm going to show you something that's in Schoology for you. This is in notes for you, and this list that I've highlighted is known as the list of perfect squares, just up to 225. And it's a really great list for you guys to memorize, especially moving on to geometry. You're going to need to know these. And this is how you're generating this list. 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, etc. And anything that is in this list, the one that's highlighted, those are known as perfect squares. And these are really unique numbers. And anytime you see one of these numbers in a quadratic, usually factoring it is pretty straightforward. Some of you are going to start seeing patterns, and you're not going to have to always do the generic rectangle or the diamond problem because you're going to recognize this list. Again, I highly recommend memorizing this list. It's going to pay off the next 2-3 years in math. But I just wanted to share that with you. And we can see that the number 9 is in this list. It's a perfect square. And that's how I knew this guy was going to be a nice 1-2 factor, is because of that 9 right there. I know that the only two numbers that, I know that it's a perfect square, so the same number, 3 times 3 gives me 9, and that's how I could quickly do, 3 and 3 is 6. Okay, just something to think about. You never have to go quickly or use shortcuts. Just do these 6 steps every time and you got it. But if you start seeing those patterns quickly, use them. Okay, so here's example number 2. And again, I really want you to pause and think about how you would do this. Try it on your own, turn the video back on, see if you got it. So we're going to factor this quadratic, 9x squared minus 4. The red flag should already be going off because 9 and 4 were in that highlighted list. They're both perfect squares. Okay, but what's wrong with this one? This one is not a trinomial. We don't have any x pieces. So how can that be? Well, I'm going to move this over a little bit, and we're going to take a look at what this means. We do have x pieces. There's just 0 of them. So when you get to one that looks like this, it has a special name. It's called the difference of two squares. You don't have to memorize what that means. That's just the name we give them. All you have to know is, oh, they didn't directly tell me this, but this is what it means. It means 9x squared. I have 0 x's. Just write it in there. Okay, minus 4. And if you factor this, life is going to be much easier. Just think of it as 0x tiles. Okay, so first step is always the same. Make yourself a generic rectangle. We have 9 large x squared tiles, and we have -4 units. Okay, step 2, multiply the diagonal, and 9x squared times a -4, you got to pay attention to the negative here, is a -36x squared. Again, that -36, if you look in our list of perfect squares, 36 is a perfect square. And now you need to set up the diamond. So what multiplies to a -36x squared, but adds to 0? Remember, we don't have any x tiles to work with. But it's a part of the problem. It doesn't mean we can't do the problem. It just means we have 0 tiles. So -36 multiplies to -36 and adds to 0. I want you to pause the video here, and I want you to try to figure this one out. Okay? Really think about those factors of 36 and see if you got it. All right, welcome back. Let's see if you solved the diamond. What multiplies to negative 36 but adds to 0? Because it's in the perfect square, we know 6 times 6, but that negative is tricky. So 6 times a negative 6, well, that gives me my negative 36. And 6 plus a negative 6, well, those cancel each other out and we're left with 0. Now I can go ahead and find my generic rectangle. So again, pause the video, fill in those question marks in your generic rectangle and see if you can find the base and the height. Okay, it's really important to see if you can do that. All right, see if you got it. Those boxes are filled in with negative 6 and 6, and you should get a base if you wrote it like mine. Now remember, if you flip the negative 6x and the positive 6x, it'll be a little bit different, but if yours looked like mine, then that base would be 3x plus 2. And my height is going to be a 3x minus 2. Interesting that you're really just looking at square roots on this one, okay? Square root of 9 is 3 and the square root of 4 is 2. Notice what the answer looks like. 3x plus 2, 3x minus 2. When you start working these independently and you get one of these perfect square, okay, or difference, meaning subtraction, of two squares, 9 and 4 are square numbers, see if you can see some patterns. Make it easier on yourself when you factor, okay? So the only trick on this one, no different, is that just throw in that 0x at the very beginning, and then you work the problem exactly the same. Okay, just because there's 0x tiles doesn't mean we can't do the problem. It just means we got to think about it a little bit. Okay, this is our last example. After this, you're going to try 4 practice problems, just like the other 2 sections, and then do a review preview. Okay, again, this practice is really important for you to do independently. If you're struggling and you need help, reach out. We will help. So we're going to factor this trinomial. Okay, it's x squared plus 5x minus 7. Again, this doesn't look any different than what we've been working with, okay, but it's in the answer again. So nothing new here. Step 1, you need to write out your generic rectangle. X squared, bottom left, negative 7 units, top right. Okay. Step 2, multiply that diagonal. X squared times a negative 7 is a negative 7x squared. Okay, I want you to pause the video here, and I want you to do step 3 and step 4. I want you to see if you can set up the diamond and then solve it. All right, welcome back. Step 3, set up the diamond. So we're looking for 2 numbers that multiply to negative 7, but then add to 5. So let's think about our factors of 7. 7 is a prime number, and so we only have 1 times 7. That's it. That's all we got. And so if it's negative, that means one of the 7 have to be negative. So if I take negative 1 times 7, that gives me negative 7. But when I add those, a negative 1 plus 7, what? That gives me 6. Ooh, so close, but it is not 5. And if I switched them, if I had 1 times a negative 7, yep, I'd get negative 7, but 1 plus a negative 7, again, that would give me negative 6. So what can we do? There is nothing that will multiply to 7 but add to 5. So we can't finish the diamond, which means we can't finish the generic rectangle, which means our answer is not factorable yet. And unfortunately, we're not going to be able to finish this chapter. We ran out of school year, but don't worry, you'll see this again in Algebra 2. We're really looking for something when we factor. And what we're looking for, guys, is the x-intercepts. And so just because we can't factor this doesn't mean there are no x-intercepts when we graph this. Remember, X squared plus 5x minus 7 gives us a graph. It gives us that parabola. It gives us that U that you did that very first week of school. And we looked at the y-intercept and the x-intercepts. And when we factor, we are focused on finding the x-intercepts. We just haven't gotten there yet. We're just having you practice factoring, okay? But the end goal of this is to be able to find the x-intercepts. And just because we can't find any factors for like this one, it doesn't mean there are no x-intercepts. It just means we have to try something else. This is where I think Algebra 1 and Algebra 2 become really interesting, because one method doesn't work, so we move to another. And that's the fun part of trying to keep it all together. So if you run into a problem that's like this, and you can't finish the diamond, and you can't finish the generic rectangle, your answer will be not factorable. But just keep in mind, that doesn't mean there are no answers, and that doesn't mean there's a graph. It just means I gotta learn some more math before I can figure this one out. Okay. Well, enjoy 813. Remember, do the 4 practice problems and then try the review previews. Keep working hard, and we will see you for 814. Have a great day, guys.